Now we discuss our autonomous model. So to construct our proposed model, first we assume that xt and yt be the densities of prey and predator population. Xt is the density of prey population and yt density of predator populations within an environment at time t greater than 0. Then the Leslie-Gould model with Holing type 2 functional response is given by this. So dx dt represent the rate of change of prey density with respect to time. It's equal to r0 minus r1 minus r2 xt minus this whole into xt, and dy dt the rate of change of predator population density with respect to time, and which is represented by r3 minus yt divided by kxt plus m0. And we have discussed that the carrying capacity for predator population is proportional to prey species, that is k into xt, and to prevent the mathematical singularity we add this term m0. So in Lotka-Volterra model there is a direct consumption of prey population by predators, that is this functional term, that is interaction between prey and predator population lambda xtyt divided by 1 plus h lambda xt, and it will convert the biomass by a conversion factor. So here k represent the role of conversion factor from prey biomass to predator biomass. So here r0 is the per capita birth rate of prey population, r1 is the per capita death rate of prey population, r2 represent the strength of interspecies competition among prey population, and this is the Holing type 2 functional response. Not this is lambda xt by 1 plus h lambda xt is the Holing type 2 functional response, where lambda is the encounter rate of prey population by predators, h is the handling time, and xt yt are the density of prey and predator population, and here r3 is growth rate of predator populations, and m0 is a constant which influences the carrying capacity for predators due to additional food sources. So the description of all these parameter we have discussed here: r0, r1, r2, lambda h, r3 and m0. So we have discussed. So in this study our main aim is to incorporate a maximum value for the encounter rate. So what is encounter rate? Encounter rate was the encounter rate was denoted by lambda. Let me choose this. Encounter rate was lambda, that is this. It was denoted by lambda. So we have to choose thinner. And as we aim to incorporate maximum value for this encounter rate lambda, we choose lambda as a function of y, that is lambda 0 plus my divided by n plus y. So it is dependent on predator population. As predator population increases, the encounter rate increases, but it has a maximum value, that is m. So lambda 0 plus m is the maximum encounter rate that can happen in this system. So here n is the half saturation constant. This means that density, Pareto density at which the encounter rate becomes half of its maximum value, that is at n equal to y, this term becomes m by 2, and by calculating this we get this functional form lambda 0 into n plus lambda 1 yt n plus yt. So here lambda 1 is nothing but lambda 0 plus m. By calculating we can obtain this, which is the maximum predation rate in the presence of hunting cooperation, and lambda 0 is the maximum predation rate in the absence of hunting cooperation. What is hunting cooperation? The many species cooperate each other when they hunting prey population. So for this hunting cooperation behavior, prey population consume prey species easily and the predation chances increases, and m signifies the highest rate of hunting cooperation, n stands for half saturation constant.